Hello, welcome back to part 2 of paper 1. In this video, we are going to solve questions 9 to 16. This is the first question in part 2. Represent minus 2 less than x less than or equals to 4 on the number line. So you need to understand the meaning of each of these symbols. If you have less than, so that means the circle will not be shaded. If you have less than equals to, the circle will be shaded. Okay, so for less than, it will be a circle like this. For less than or equals to, it will be a shaded circle. So equally, if you have greater than and greater than or equals to, so this will be an open circle, a shaded one, while this will be shaded circle. Okay, so if you have less than or greater than, so you wouldn't shade the circle. But if you have greater than or equals to or less than or equals to, so you have to shade the circle. So this is the first thing you need to take note. Also, if a number is less than, okay, so you have to watch out for this tip here. For less than, always watch out for this. Okay, for greater than, so you always watch out for this. So that means it will be facing this side for greater than, and for less than, it will be facing this side. Okay, so we need to firstly deal with this. If you have minus 2 is less than x, so it means x is greater than minus 2. So this is very important, okay, because this is the only way you can connect the two together here. So if minus 2 is less than x, that implies that x is greater than minus 2. Okay, so if you want to use greater than, that means you have to watch out for this tip here. So that means the line will be drawn towards this direction because of this greater than. Okay, so that means we're going to start from -2. We draw the circle there. Okay, and it goes towards this direction. Okay, for now. So because of this greater than, okay, if you look at the tip of the greater than, it is here. So that means it has to face this direction. Okay, so and since it is only greater than, so we wouldn't shade the circle, just like what I explained earlier in this video. Then the second part is that x, because for this now, x continues to increase, okay, and it has to end somewhere. Okay, so that is what the second inequality takes care of. So x is less than or equals to 4. So as the x increases like this, so it gets to this spot here, okay, and it ends here. Since we have less than or equals to, so we have to shade the circle like this. Okay, so this will be the boundary here, so you can connect these two together. Okay, so the numbers that are involved now will be from, if you're taking the integers, you have -1, 0, 1, 2, 3, and 4. Okay, so these are the numbers within this range. Okay, so although this started from -2, but we didn't shade it, so that it implies that -2 is out of the range. Okay, so that's the implication. So we have -1, 0, 1, 2, 3, and 4 to be the numbers in this range. So this is pretty easy. Okay, so let's go to the next one. That is question 10. Okay, so let's scroll down gently. The diagram shows a shape made with 3 identical rhombuses. Okay, so find the value of x. Okay, so to tackle this problem, you need to firstly understand some properties, that is the angle properties of a rhombus. So for a rhombus, the opposite angles are equal. That is, this angle x here is equal to the angle here. So because they are opposite angles of a rhombus, okay, so this angle here, okay, is equal to this angle here. Okay, so another property you should take note is that two adjacent angles add up to 180 degrees. So if I call this angle X, okay, then let's call this angle Y. Okay, so X and Y are adjacent angles of a rhombus, so the two angles add up to 180 degrees. So do these two angles, they also add up to 180 degrees, and everything will give you 360 degrees as the sum of angles of any quadrilateral. Since these three shapes are identical rhombuses, so the implication is that the angle here will also be angle Y, and the angle here will also be angle Y. Now we have angles around this point here. We need to find the value of Y using the theorem angles around a point. Okay, so they add up to a 360 degrees. So we can use that to get the value of Y. So that means Y add Y, that will be 2Y. 2Y add Y, that will be 3Y. So we have 3Y add then 70, 70, 140. So 140 add 70, that will be 210 degrees. You can easily say 70 multiplied by 3. That will give you 210 degrees, as 3 times 7 is 21. Then you add the 0 behind it. So these add up to 360 degrees. Okay. Then we can now rearrange by collecting the like terms. We have 3y to be equals to 360 degrees minus 210 degrees. Okay. Then you have 3y to be equals to 150 degrees. So divide both sides by 3. So 150 divided by 3 gives 50 degrees. So that means each of these three angles is 50 degrees. Okay, so y is equals to 50 degrees here. Okay, so from this, don't forget that earlier in this solution I told you that this angle and angle X are adjacent angles, and I told you that they add up to 180 degrees. Okay, so we can say angle X plus angle Y, okay, will be equals to 180 degrees. Then angle X plus angle Y is equals to 50 degrees, equals to 180 degrees, and X is equals to 180 degrees minus 50 degrees. Then X is equals to 130 degrees. So that will be the value of angle X. So let's go to the next question. That will be, okay, so let's scroll down. We can put the value here. X equals to 130 degrees. So we can go to the next question. So that will be question 11. Okay. Sorry. Oh no. So let's go to the next question. That will be question 11. Gabriela collects the height of 11 indoor plants and 12 outdoor plants. The table and the incomplete back-to-back stem and leaf diagram show information about her results. So this is for outdoor plants. Okay, you have the mother height, we have the minimum height, and we have the range. Then for the indoor and outdoor stem, back-to-back stem and leaf diagram. Okay, so we have this, and we've been given the key. Okay, this is very important. So this is the key. So it represents, if you go like this, it will be 23, and if you go like this, it will be 26. Okay, so for the indoor, okay, which is by the left hand side like this, okay, it will be 26, and for the outdoor to be the forward one, that will be 23. Okay, so good. So what do we need to do here? So let's scroll down. Use the information in the table to complete the back-to-back stem and leaf diagram. Okay, so what we need to do here, let's scroll up a little bit. Okay, now we need to start from this given information, that is for outdoor plants. The modal height is 39, so that it means that 39 appears most. Then the minimum height is 17 centimeters, okay, and then range is equals to 26 centimeters. So from this we can get the highest number, so making use of minimum height and the range here. So let's write something here. So the range, okay, is equals to the maximum. So let's say max for the maximum, then minus min for the minimum height. Okay, so the range is 26. Okay, the max we don't know, let's put the max there, then minus the minimum. So the minimum height is 17. Okay, so I can say 26 add 17. Okay, so that will be the maximum height there, and that will be 43. Okay, so you can come here. So instead of so we already have 4 1, that is 41. So we can put 3 here, so that will be for 43. That's the maximum height there. So that is what you will get if you combine the minimum height and the range. Okay, so you get the maximum. Okay, so another thing we need to look into is that the modal height is equals to 39 centimeters. So it means that 39 appears most. Okay, so if you look at the diagram, so 27 already appears 2 times. If you look at it for the outdoor plant, so that is 27 and 27. Okay, so it already appears 2 times. So that means 39 must appear more than 2 times for it to be the modal height. So it has to appear at least 3 times. Okay, so if you look at what we have here, you already have 39 once here, right? So that means we can add 9 here. So this will make it 2. Then we'll add another 1. So this will make it 3. So that means 39 is the modal height. Okay, so don't forget that so far so good, we have used 2 numbers, right? So we used this one, that is 43, 39 and 39 again. So that is so we have 3 numbers, and we need to complete the stem and leaf diagram. So we have only 1 number left. So let's see what we need to do, because for the indoor plants, okay, you have 11 numbers. So for the outdoor plants, we have 12. And if you look at what we have currently for the outdoor, so you already have, so let's start from here, 1 2 3 4 5 6 7 8 9 10 11. Okay, so we have 1 left. So where would that be? That would be the minimum height. So the minimum height is 17 centimeters. So you have 1 here. So we need to put 7 here. So that will be for the minimum height. Okay, so we are done, because we are given for 8 numbers. By default, 1 2 3 4 5 6 7 8. Okay, so we have to add 4 numbers to make it 12 as stated above here. So that is the solution to that question. So it has part B. For part B, calculate the range of height for the indoor plants. Okay, so the range will be the maximum height minus the minimum height. So let's scroll up. Okay, so if you look at the maximum, So the maximum will be 30, and then the minimum will be 0.7, that is 7. So we can scroll down. Okay, so we'll say that the range, so let's write this, the range, okay, will be equals to the max minus the mean. Okay, so the max will be 30 minus the mean, that's 7. So this will give us 27 centimeters. So that will be the range of the indoor plants. So the next question is question 12. Work out the value of n to the power of 4 plus 29 over n plus 7 when the value of n is equals to 3. So what you need to do here is to substitute the value of n. So that will be equals to n equals to 3. It will be 3 to the power of 4, then add 29 over n is what's it called, 3 again, then plus 7. Okay, so you can actually do this. So another thing you could try to do, okay, so I think this will be very easy for us to do. Let's simplify this. 3 to the power of 4, that will be 81, that is 3 multiplied by 3 multiplied by 3 multiplied by 3, that will be 81. Then add 29, everything over 3 add 7, so that will be 10. So 81 add 29, that will give you 110 divided by 10. Of course, the last 0, we always cancel the last 0 here. So we have our final answer to be 11. So the next question will be question 13. Write 62,000 in standard form. A number is said to be in standard form if it could be written as a multiplied by 10 to the power of n, where n is an integer. So, and the value of a is always between 1 and 10. Okay, so it cannot be up to 10 and it cannot be less than 1. So that is the standard form number. So you need to take note of that. Okay, so if you have 62000, so if I put the decimal point here, of course, is more than the condition, as the standard form number can only be between 1 and 10. Okay, so if I put it here, it will be 620. If I put it here, it will be 62. If I put it here, it will be 6.2. So that means this will be the correct one. 6.2 times 10 to the power of what? So I have the decimal point here now. So let's count to this point here. So it will be 1, 2, 3, 4. So it will be 10 to the power of 4. So we have 6.2 times 10 to the power of 4. So that is what you get there. 13b, write 8.1 times 10 to the power of negative 3 as an ordinary number. So you have 8.1, okay, times 10 to the power of negative 3. So you have to shift the decimal point towards this direction, okay. That's where you have negative. If you move forward, just like what we did here, so we got positive 4. So if you move backward, so that will be negative number, okay. So since we have a power of negative 3, so we shift the decimal point towards this direction. So it will be 1, 2, and 3. So the decimal point will be here. So this will be filled up with 0 and 0. So we have 0.0081. But it's always good to precede a decimal point with a 0. So we need to put 0 here. And that will be the answer to that question. So the next question will be question 14. The diagram shows a shape made from 6 congruent equilateral triangles and a regular hexagon. So the regular hexagon means that this side, this side, this side, this side, this side, and this side are equal. Okay, so another thing is that we have equilateral triangles. Okay, so that means this side, this side, this side. Okay, so all the three sides of the triangle are also equal. So that is the implication of what we have here. Okay, so the regular hexagon has an area of 140 squared centimeter. Okay, so calculate the area of the shaded portion of this diagram. So let's scroll up a little bit. I'm sorry, so that's too much. Okay, so we need to scroll up a little bit. Okay, almost there. Okay, fine. So this is pretty easy. So if you look at the mark here, it's just 1. Okay, so the implication is that the area of this, because if you fold these triangles into the regular hexagon, okay, so all these vertices of the equilateral triangles, okay, so we meet here. So that means the area of this regular hexagon will be the area of these 6 equilateral triangles. Okay, and out of these 6 equilateral triangles, so 3 are shaded. Okay, so and 3 are unshaded. They are not shaded. So that means the area of these shaded triangles will be half of the area of the hexagon. Okay, so to hit it straight away, so you can see that the area will be equals to 140. Okay, so you can divide it by into 2. Okay, so that will be the area of the shaded triangles. Okay, and also it will also be the area of the unshaded as well too, because they are similar. Okay, so this will just be 2 goes in 14 7 times, 2 goes in 0 0 times, so we have 70 centimeter squared. Okay, so let's scroll down for the next question. So I think that should be the last one there. So the next one will be question 15. Question 15. The table shows information about the mass of each of 23 boxes. So we have them here. So on the grid, draw a frequency polygon to show this information. Okay, so let's scroll up a little bit so that you can see the table as well as the grid. Okay, so for the first one, we need to find the midpoint. Okay, so that will be 4 add 8, that will be 12. 12 divided by 2, that will be 6. Okay, you can do that from here. Equally, you can also use the grid. So the midpoint of 4 and 8 will be here. The midpoint of the next one, that is 8 and 12, it will be here. So the midpoint of 12 and 16 will be here. Okay, so you can equally do it from here if you don't want to use the table. Okay, if you want to use the table, add the two numbers together and divide by 2. If you want to use the grid, just always pick the middle. Okay, so that is it. So when for this interval, the first one between 4 and 8, so the frequency is 8. So the frequency is 8. So the middle, then it should be somewhere here. So let's mark this one here. Then between 8 and 12, the frequency is 7, 8 and 12. Okay, so the frequency is 7. It will be this spot. Okay, so between 12 and 16, the frequency is 3. So it will be this spot here. Okay, so between 16 and 20, the frequency is 2. So it will be here. Okay, then between 20 and 24, the frequency is 3 as well. So it comes to this spot. Okay, so now you need to connect these together. So what you can do, you can actually use a ruler. Okay, but for me, I can draw a line straight away like this. So let's join this and this together. Good. Then you can also join this and this together. Okay, good. Then join this and this together. Good. And finally join this and this. Okay, so that is the frequency polygon. Okay, you have to complete it like this. Then let's see the next question. Okay, so draw a ring around the interval that contains the median class. Okay, so if you go back to the table, okay, so look at what you have here. So even from the grid, look at it, is between okay, let's do this. So you have the first one, you have between numbers between 4 and 8, they appear 8 times. So that means you're going to have 8 numbers. Then numbers between 8 and 12, okay, so you're going to have another 7 numbers, okay, and so on and so forth. So the total number you're going to have here, as stated here, will be 23, okay. So that means the middle number will be between the 11th and the 12th number, right? It will be between the 11th and the 12th value, okay. So since we have the first 8 numbers here, or masses here, okay, so the 11th and the 12th will fall within this class, okay, this range. So we can go to the question and circle between 8 and 12. So this will be the correct option. Okay, so let's go to the next question. That will be question 16. So you have 1 over 9 to be equals to 0.11111. So this is a recurring decimal number. So if 1 over 9 is equals to 0.1, so this dot here tells us that 1 is a repeated digit, so it is the same as 0.1111 like this ellipsis, or 0.1, then you put a bar. So these are the 3 ways you could write a recurring decimal number, okay. So if 1 over 9 is equal to this, use these facts to convert 7 over 9 to a decimal. So 7 over 9, okay, let's say 7 over 9 is the same as 7 times 1 out of 9, okay. So it's the same as 7 into, so you have 0.1. So we are asked to give our answer correct to 3 decimal places. So you can have, so that means you have to have 4 digits, 1, 2, 3, 4. Then you can now show the ellipsis like this if you want, okay. Or better still, you can just put a dot here, put a dot here, okay. So it's still the same. So if you expand this now, if you multiply 0.1111 by 7, so this will give us 0.7777 and dot dot dot. So if you now round it to correct it to 3 decimal places, so this will be approximately 0.778. So we have 0.778. Okay, so let's go to the last question in this part, that is the last question of part 2. So that will be question 17. Okay, so Jamila makes this sequence of patterns using white counters and black counters. Okay, so this is the first pattern. This is the second, third, and fourth patterns respectively. Complete these sentences. The first one has been done for you. So Cambridge is well known for this. So the number of white counters in pattern 4 is this. That is 1, 2, 3. So that is 4 numbers and 3 rows. 4 times 3, 12. Then 13, 14, 15, which is correct. So the number of white counters in pattern 5 is this. So you can use the same method here. So if you have pattern in pattern 4, so you have 1, 2, 3, 4. You have 4 rows. So for pattern 5, so you're going to have 5 rows, and you're going to have how many circles? 1, 2, 3, 4, 5. That is 5 columns. So let's start. So you can do 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 4 rows. Okay. So this is the fifth one. 1, 2, 3, okay, 4, and the last one will be for, okay, for the two black circles as is constant, okay, in all the patterns. So we put this one here. So let's shade this one like this, okay, then you put another one on top, okay, so we also shade it, okay. So the number of white counters in pattern 5 will be, so this is 5, 10, 15, 20, then 1, 2, 3, 4. So we have 24. So this is what we're going to get here. So we can write 24. So this is the easiest way to get it. So alternatively, you can form a sequence for the white counters. Okay, so for the first pattern, when n is equals to 1, so let's write something here. Okay, so when n is equals to 1, okay, so we have 0 white counter, so you can put 0 here. This is for white. Okay, so we can put it there. So for pattern 2, okay, we have 3 white counters. So for pattern 3, you have 1, 2, 3, 4, 5, 7, 8. So we have 8 counters. So for the fourth, okay, so we have 15 white counters. So for the fifth, okay, so let's say we don't know this, so we can actually check what we have here. Okay, so the pattern you can just use here is to say, let's find the difference. 3 minus 0, you have 3, that is this and this will give you 3 if you subtract. So 8 minus 3, you have 5, then 15 minus 8, you have 7. Okay, so if you look at this, you can see that the difference is increasing by 2. So that means to get the next one here, it has to be 15 add 9. Okay, 15 add 9 will give us the answer here. Okay, so which is 24. Okay, we still have the same thing here. Okay, then the next part is the number of white counters in pattern 100. So of course it will be crazy to start drawing the patterns here. So this is where we try to use the nth term, okay, for the sequence. Now you can see that here we have the first difference, okay. So this is the first difference, okay, and we don't have common difference. So if we go again, this 5 minus 3, you have 2, 7 minus 5, you have 2, then 9 minus 7, you have 2. Okay, so this is the second, okay, difference, and we have common difference at the second difference. So that means this is a quadratic sequence, okay, and the first thing we need to do is to divide the common difference by 2 and multiply by n squared. So we're going to have 2, so this 2 is the common difference here, then divided by 2, okay, so multiply by n squared, okay, so this will give us n squared, okay, so this is part of the nth term, okay, so I can just write something here, so I can say that the nth term, okay, is equals to n squared, but I'm not done. So let me write the initial sequence, okay, or the old sequence, which is 0, 3, 8, 15, yes, and 24. Okay, so this is the old. Okay, so the new sequence, okay, will now be from this when the nth term is n squared. So that is 1 squared. Okay, it will be 1. Okay, 2 squared will be 4. 3 squared will be 9. Then 4 squared will be 16, and 5 squared will be 25. Okay, so we need to subtract the new from the old. So 0 minus 1, okay, so that will be minus 1, minus 1, 8 minus 9, minus 1, 15 minus 16, minus 1, 24 minus 15, minus 1. So since we have common difference of minus 1, so we just have to add minus 1 to our n term here, it should not be n squared minus 1. Okay, so this is what we're going to use to get the number of white counters in pattern of 100. Okay, so since we have this, it is easy for us to get the number of white counters in pattern 100. Here n is the position, okay, is the number of patterns, okay, and the nth will give us the number of white counters there. So you may want to check this nth term if it is correct or not. Okay, so when n is 1, that's the first term, okay, for the odd sequence. Let's see. So you have 1 times 1, 1 minus 1, 0. So this is correct. So when n is 2, that's the second term. 2 times 2, 4. 4 minus 1, 3. When n is 3, 3 to the power of 2, 9. 9 minus 1, 8. You can see this is correct. So we can now use this to get the number of white counters in pattern 100. So you can say n is equals to 100. So it will now be equals to 100 squared minus 1. Okay, so this is, you can write this as 100 squared, then minus 1 squared. Then you can now use difference of two squares because 1 squared is still 1. Okay, so this will be 100. Okay, 100 minus 1, okay, into 100 plus 1. Okay, so this will be 99. Okay, 99 multiplied by 101. So if we do that somewhere here, so let's manage and do it here. We have 101 multiplied by 99. So this will be 9, this will be 0, this will be 9. So 0, so you have 9, 0, 9. So if you add, so you have 9, 9, 9, and 9. So you have 9,999. So it will be here. So you have 9999. Okay, so part B, write an expression in terms of n for the total number of counters in pattern NO. You can see we've already done that here. Okay, so that is what I actually did here. Okay, so it will just be the nth term. So okay, so the nth term, okay, will be equals to n squared minus 1. Okay, let's write that. So it will be nth term, okay, will be equals to n squared minus 1. So and we want to write this as n minus 1 multiplied by n plus 1. That is the difference of two squares. So as 1 is the same as 1 squared. Okay, so we can do that. So this is the end of solution to part 2. Okay, so in the next video, that will be part 3. So we're going to solve the remaining questions. Okay, until then, have your fingers crossed.